Welcome to the Math Record. Today I'll be covering the ICTM Regional 2017 Division AA Geometry. In this video, I'll be covering questions 5, 17, and 18. And next video, I'll be covering question 19 and 20. Okay, so I'll scroll through all 20. Okay, now let's begin with number 5. So the sum of the lengths of two diagonal in a quadrilateral ABCD is 44. Determine the perimeter of the quadrilateral formed by joining the midpoints of the consecutive sides of the quadrilateral ABCD. So let's just kind of draw a general shape of how this looks. So we have some kind of quadrilateral. So something like this, and then like that. It doesn't really matter. It just has to be four-sided. And then we have basically two diagonals. So something like this. Usually in geometry, you would like to draw pictures to see how it's happening. Okay, so we know that the sum of these two diagonals is 44. And then they said that determine the perimeter of the quadrilateral formed by joining the midpoints of the consecutive sides. So we have midpoints that connect to this, and this one connects to this one, and then this one connects to this midpoint here, and then we have this one connected to this. So how do we know what the sum of this perimeter is? Well, if you kind of think about it, we have a bunch of triangles. We have this triangle, and we have this triangle. Since this triangle is made by connecting the midpoints, that means this length is half of this length. But you could also say, using this triangle and this triangle, this is also connecting the midpoints, so that this length is half of this one. So if this and this are both half of this, then adding them together will give us just this diagonal. And the same case could be said with this and this, which is half for this, because this triangle is half of this, and this triangle is half, and I mean this triangle is half of this, which makes this diagonal. So these two make this one, and these two make this one. So then if you add them together, it's just the sum of the diagonals. So the answer for number 5 is just 44. And that's basically it. So you don't really need to prove it too much, just think about it logically. Okay, now number 17. So ABCD is a parallelogram with EDC, where with points EDC are collinear. AE is perpendicular with EC, and FG is perpendicular with BC. FG is 60, AE is 24, and the perimeter of ABCD is 182. Determine the numerical area of ABCD. Okay, so let's kind of draw a general picture of how this looks. So we have some kind of height, then I have some kind of length, another one right here, and I'll just make this a bit bigger because it's kind of hard to tell. And like that, and like this. And then we have another one. So this is just a general picture. It's not really that exact. So what I noticed that we have this line over here. We know FG is 60 and we know AE is 24. So AE, we could just call this 24. And let's just say we have a height right here to here. And that length, which is 90 degrees, is 60. And we know that the perimeter of this, basically this line, is equal to 182. And we know that it's a parallelogram, so that this length is equal to this length, and this length is equal to this length. So if we divide by 2, that is 182 divided by 2, that's 91. So if I call this length, let's call this length x, then I could call this length 91 minus x. So how do I find the area of ABCD? Well, it's simple. Just think of base times height. So if we're thinking about this as our base, then what is our height? Well, it's 60. So 60 times x is our area. Now, what happened if this is not the base and this is the base now? So our base is 91 minus x. So what is our height now? Well, it's 24, right? Because if you draw a height, it's the same thing. It's just 24. This is 90 degrees, right? So it's kind of just weird, but if you kind of think about it, just move this line over, and that would make our height. And that's basically why I drew that line. So now we have this equation, and now we just need to solve for it. So this is 60x, and this is minus 24x, so that makes 84x. And then this is 91 times 24. And then you can just basically use your calculator if you want, but you can also just do this by hand. But I prefer using the calculator. So 91 times 24 divided by 84 times 24 divided by 84. And you get an answer of x is equal to 26. But that's not what we're looking for. We're looking for the area, so we need to plug it back into one of these. I'll plug it into 60x because it's easier. So 60 times 26, and we get an area of 1,560. And that's our answer for number 17. Okay, now number 18. A quadrilateral with consecutive sides of 28, 80, 60, and 96 is inscribed in a circle of radius 50. Determine the numerical area of the quadrilateral. So we have some kind of circle, and we have a quadrilateral inside it. So I'm just drawing this a diagram. When I do the math, we kind of don't really need it actually. Uh, I'm just drawing a general thing. It's not to scale. Every single time you draw a diagram for geometry, it generally doesn't really scale. And then we have 28, we have 80, we had 60, and we had 96. Okay, so I just put them in as the order as I saw it, so it doesn't really matter. So there's actually a formula to find the area of this. It's called Brahmagupta's formula, or however you say the name. But basically, all you have to do is add all these side lengths together and divide by 2. So 28 plus 96 plus 80 plus 60, and then divide by 2, and you get a number, which is 132. And then from this number, you subtract all these four numbers from this number, so then you get four numbers. So 132 minus 28, we get 104. And 132 minus 96, we get 36. And 132 minus 60, that is 72. 132 minus 80, that equals 52. And then from there, you're going to multiply all these four numbers. So 104 times 36 times 72 times 52. And then you're going to take the square root of that number. And you should get an answer of 3,744, right? So that's the general procedure how you find it. So the general formula is just S minus A, S minus B, S minus C, and S minus D, where A, B, C, D are the lengths of the quadrilateral, and S is equal to A plus B plus C plus D over 2, which is basically what we did. So we add them together, divide by 2 to get this number, and then we subtract each of those numbers from 32, which is this, and then we multiplied them together, and then we took the square root, which this is how we got our 3,744. And that's basically it. But this only works for quadrilaterals inside a circle. Okay, so don't use this for every single quadrilateral. So that's our answer for number 18. Okay, well that basically completes our first part of our geometry. Thanks for watching, and let me actually show the answers first. Thanks for watching, and I'll see you at the next math record.